So I decided to go ahead and Eric had asked me to work this problem again. And so I'm doing it formally, but I think the problem with the solutions I came up with is worth videotaping. So here is, this is problem 9A from in the year 2020, fall 2020. This is sheet number 212, 2.12. So maybe it'll be different, probably be in 2021, it'll probably be somewhere in packet 3. But it's the, let's see, it's the packet, it's the sheet that is, it's called Orange Kinematics. You must use CLDPA method to solve. So that's the one I'm on. Anyway, so this is number 9, and I started it here, and I'm just going to erase. I've worked some of the problem. The more interesting problem is part B. So let me go through. So far, little CLDPA, you have something that's slowing down, so it has a negative acceleration. Okay, so now we got to write our equation in, and I'm erasing. Okay, I'll erase my work here, and then I'll bring back my work, hopefully. Hold on a minute. I gotta check something. Let me pause this. All right, so let's go ahead and solve this. And we're trying to solve for time. So it looks like the first orange is going to work. We just find V final then equals V final, and you can work along with me here, equals V naught plus a T. I'm solving for T. So that's V final minus V naught over A. And we're just going to go ahead and write the numbers in as they are on the problem at first. So final velocity is 75 kilometers per hour minus initial velocity, which is 157. See, I'm slowing down, kilometers per hour, and divide that by the acceleration, which is -7 meters per second squared. So I see that I have a unit issue. All right, so I'm going to have to go back to some analysis. So let me just plug all this in, get the analysis going. So I'm going to go and take the difference. Well, the difference of those two is 82, -82 kilometers per hour, put hour on bottom, times 1 over acceleration. So that's -7 meters. I bring the second squared up top. I'll call it second dot seconds. Okay, and now, because that's second squared, and now I want to get this, I want to ultimately end up over here in terms of seconds. Okay, so it looks like I'll get the hours out of the way. So hour over 3,600 seconds. And green kill pin will kill that hours, kills the second, one of the seconds. And then I got to get the kilometers and meters. And so we have 1,000 meters over a kilometer. Okay, so yeah, meters die, kilometers die, and I'm left with seconds. It's all left. Okay, so I do the math there, and I find that T equals 3.25 seconds. So that, other than a little bit of unit issues, that's not a problem. Now we get down to 9B, and it says, how many meters does the car travel during this negative acceleration? Okay, there's 3 ways to do this. One way is probably the one that most students do, and that is plug into the second orange, and that'll solve it, nothing wrong with it. But let's look at these 3 ways, and you pick the one you like the best. So the second orange, delta x equals v naught t plus 1/2 a t squared. Now we know t, we know a, we know v naught. I want to put v naught in terms of meters per second. We'll just do that right there in the problem, because we never actually did that. We never actually did that up here. Up here we were looking at the difference. So I'll just do that in the problem. So we have delta x, and I guess it doesn't really say, but oh, it says meters. Okay, delta x will be in meters. So equals v naught, which is 75. So 75 kilometers per hour times 3.25 seconds. Obviously, we got an issue here. We can fix it though, and that is 1,000 meters in a kilometer, and I got it. Delta x can be in meters, so I got to kill everything except the meters, and then we have 3,600 seconds in an hour. Okay, and that is times t. We did that times t. Okay, there's my two givens. And so this is the first part of the equation plus 1/2 a, and that's -7 meters per second squared. The units are okay there, times 3.25 seconds squared. Okay. So I punch all that in. I'm going to let me pause, and I will pause this, and I'll go and get my calculator out just to make sure I'm right here. Okay, so rather than go back and do this again, I got this answer here. I know this answer is wrong. And so I did what, and students have been coming to me saying, I got this, I'll do this over and over again and keep getting this answer. Well, this is wrong. I could have gone back and just redid it, but I want to show you how I did it wrong too. This is wrong, and so the reason is I used the wrong velocity. That's supposed to be v naught t. That's 75 kilometers per hour is v final t. So let me fix this and come back. Okay, now that's right. So yeah, people that are having trouble on this, I think you might be using the wrong velocity there. Because usually we're used to thinking, and I fell for it too here. We're used to thinking that these lower velocities, the initial velocity, but this thing is slowing down. So that's the correct way to do it. Now that's one way of solving this, and that's perfectly fine, but I'm going to show you an alternate method. And I think this alternate method is a shortcut, a little bit. So the second method I'm going to do, this is method, we'll call this method 1. Now method 2, I'll do in blue for 2. So method 2 is using this equation. V bar equals delta x over t. And this is one of the equations we use to derive. And this is good. This works for it works for trios because it's V bar, right? And so trying to solve for delta x, then we have delta x equals V bar times t, which is V naught plus V final divided by 2, that's V bar, times t. And that only works, this only works for trios. Okay, so this might be a little easier. Let's do it first in the units that they gave us. So we have, got to find the average of the two. Let's go and add them up. So we have V naught, which is 157 kilometers per hour, plus 75 kilometers per hour. The unit abbreviation per hour is just H, but I put HR, times 2, times my time, which I know is 3.25 seconds. Okay, so when I do the math on that, take the average of those two. It looks like I'm going to do a little bit of unit analysis, but take the average. I have 75 plus 157 divided by 2, 116. So I'm going to get my delta x in terms of meters. And so I got 116 kilometers. Let's do a quick unit analysis here. 116 kilometers per hour times, let's get this in terms of meters per second. So 1,000 meters in a kilometer, and then an hour over 3,600 seconds, and then times 3.25 seconds, and double slash. And that'll give me, when I do the math there, that should give me 105 meters. So you see, that's a little easier than doing it the other way. Both ways work. Okay, I've got to get my dog here, and then I'll take care of her, then I'll come back and do the third method. So this third method involves using the orange trio. I mean, I didn't make it orange, but using a trio, we know that acceleration is -7. So kind of like we did that in the problem today in class, you can solve. So you got to start off by finding the area, by finding this area here. And this will tell you how much the acceleration, how much the velocity, which by the way, we already know. I know that this is, okay, so we already have the units where I want them. Let me just go ahead and use this because we know the velocity starts at a certain positive speed, which is in miles per hour is 157, and it ends up going 75. So like this, like a straight line, it's negative slope. So, but I'm looking at that, I'm going, okay, yeah, the problem there is, for me, is the unit issue, because I can't, this is going to be meters per second, but if I find this area here, this area I know will equal how far it dropped. It'll equal it'll equal how far the velocity dropped off. Okay, my loss in velocity is what that area will equal, and it'll equal it in terms of meters per second, which is what I want. So it'll save me some unit analysis. So if I have 7 times 3.25, that gives me -22. So the area equals -22.7, -22.8 meters per second. So I know that this has dropped off -22.8 meters per second. We say that this area equals accumulation, right? And the area on the integral is the accumulation. Well, here I'm accumulating negative area because it's slowing down. So I know that for this now, to solve this, this is 3.25 seconds. This is -22.8 meters per second is how much it lost. So if I find this area here, I find the area of this right triangle, that'll tell me how much distance it traveled between the two times. I don't know the ultimate distance. I don't have that. I don't have the precision, but it'll give me how far it went in those 3.25 seconds, or as that velocity was slowing down from, because this, I don't even know. That's a cool thing here. I know that's 157 kilometers per hour, and that's down here is 75. I don't even know what those are in meters per second, but I don't need to worry about it. See what I mean? Because I've already got that. I already know what the difference is right there from that. That's the difference. That's how much that's how much speed I lost. Okay, so this area now will give me my area here will give me my delta x. And notice that it's no longer negative area. I'm in the first quadrant. So that area will be positive. So 1/2 base times height will be 1/2, and my units are good. Base is 3.25 seconds. Height is negative. I know I'm in the first quadrant, so I know it's positive. 22.8 meters per second. I know it dropped, but I'm still in the first quadrant, so my velocity never went negative. So that's interesting. It's sort of like the absolute value in that case. Can't always say that, but if it's in the first quadrant, it's like absolute value. So I'm just going to leave it as positive. I just thought of this method a minute ago, so let's see if this works. On live Zoom, 0.5 times 3.25 times 22.8 is 37. My delta x is really 105. All right, now let me think through this one, because something ain't right. Let me figure this one out. Okay, I see where my mistake was, and that's what I get for trying to make up some kind of crazy rule on that absolute value. No, that is negative. This you cannot, do not doubt physics, like I just did. That's negative 22.8 meters per second. There's a reason why that's negative. So I was thinking this is like a typical trio, but it's not, because there's a V naught. Normally there's a V naught T here. So this, if there was no negative acceleration, if all we had like a red, it was a red duet, then what would happen to the velocity is this, right? I mean, sorry, the position. It would just be that 157 kilometers per hour, which I converted that here to, that's the same thing as 100. I just did the quick conversion here. That's 157 kilometers per hour. Converted it into meters per second times 3.25 seconds. That puts me at 142 meters. That's if there were no negative acceleration. It's that what that negative acceleration did was it then was this green triangle, and it pulled away some of the position that I would have gained. So instead of getting 142, my area here is, when I do this, the green area is 22. Oh, okay, so 22.8, 1/2 base times height. Daggone it. Okay, 1/2, now 1/2 base times height is 0.5 times 3.25 times 22.8 gives me negative, that's going to be negative 37 meters. Okay, so if that's how much I lost 37 meters due to that negative velocity, due to me slowing down. And so the actual final position is 142 minus 37, or 105 meters. And so this, you might think this is connected up by a parabola that does this. No. This is a negative parabola. So it's hooked up by a parabola that starts off going this way and then loses until, and that's probably too much loss, because it wasn't at the turnaround point. It didn't drop to zero velocity. So my slope there's a little off. Let me go back and try it again. So it's coming up, and then it's still going up. It hasn't reached its apex yet. So this is a little bit beyond where we're at right now, but I thought that was interesting. That is another way to solve it. It's a third way to solve this using, which I would not suggest yet. We're going to get better at this later. Okay. So that was how to work that problem, more than you wanted, but I will stop this, put this on the YouTube channel.